Take a moment and think about this. Even if you had no list, no computer, and no calculator, combining two apples would still give you two apples. The planets in our solar system continue to move along their orbits as if they were following an invisible equation, whether we notice it or not. Even a single note you hear when you pluck a guitar string is, in reality, a reflection of the mathematical order hidden within frequencies. But have you ever wondered this? Is mathematics a real language woven into the fabric of the universe, waiting for us to discover it? Or is it a powerful abstraction created by the human mind to make sense of chaos? This question has fascinated far more than modern scientists. From Plato to Einstein, from Pythagoras to today's quantum physicists, countless philosophers and scientists have spent centuries trying to solve the very same mystery. And perhaps the most astonishing fact is this: we still don't have a definitive answer. In this video, we'll explore whether mathematics is truly the hidden language of the universe, or simply one of humanity's greatest inventions. Let's begin with a simple observation. When you look closely at nature, it almost feels as if the universe itself has been built according to the rules of mathematics. The arrangement of sunflower seeds, the flawless spirals of seashells, and even the majestic arms of spiral galaxies. Although these structures appear completely different, they can all be explained by the very same mathematical patterns. One of the most famous examples is the Fibonacci sequence. But is this merely a fascinating coincidence? Or is it a clue to a much deeper truth about the way nature truly works? In 1960, Nobel Prize-winning physicist Eugene Wigner published his famous paper, The Unreasonable Effectiveness of Mathematics in the Natural Sciences. The question he raised remains one of the greatest mysteries in science even today. Why do mathematical structures, created by the human mind as purely abstract concepts, describe the physical universe with such astonishing precision? One of the most remarkable examples of this is complex numbers. During the 19th century, many mathematicians regarded them as nothing more than an intellectual exercise. They were believed to have no connection to the real world. Yet only a few decades later, they became the indispensable language of quantum mechanics. Today, describing the behavior of electrons, the world of subatomic particles, and the fundamental laws of quantum physics without complex numbers is almost impossible. Another extraordinary example is Einstein's general theory of relativity. Using non-Euclidean curved geometry, which at the time was considered nothing more than an abstract branch of mathematics, Einstein completely redefined gravity. His equations predicted the existence of black holes, the curvature of space-time, and even the expansion of the universe, years before any of these phenomena had ever been observed. It was almost as if reality appeared first within mathematics, and only later through the lens of a telescope. But is all of this merely an astonishing coincidence? Or is mathematics truly the invisible framework upon which the universe itself is built? In fact, the roots of this debate stretch back nearly 2,500 years. According to the ancient Greek philosopher Plato, numbers, triangles, and circles were not merely concepts created by the human mind. They belonged to a perfect, eternal, and unchanging world of forms that exists beyond physical reality. From this perspective, mathematics is not invented. Like an undiscovered continent, it is simply waiting to be found. Today, this philosophy is known as Mathematical Platonism, and it is still supported by many mathematicians and physicists. According to this view, if two mathematicians working independently arrive at exactly the same mathematical truth, it is because that truth already exists independently of the human mind. Prime numbers, the number pi, and the laws of geometry were there long before humanity appeared, and they will continue to exist long after humanity is gone. Modern physicist Max Tegmark takes this idea to a far more radical level. In his theory known as the mathematical universe hypothesis, he argues that the universe is not merely something that can be described by mathematics. It is mathematics. According to Tegmark, the universe is not simply governed by mathematical laws. Reality itself is a vast and extraordinarily complex mathematical structure. At first, this idea may sound almost unbelievable, but the question Tegmark asks is deeply thought-provoking. If we can describe the universe with perfect mathematical precision, is there really any distinction between mathematics and the universe? Or have we been living inside mathematics all along? However, there is another side to the story. According to many philosophers and scientists, mathematics is not a mysterious reality that exists independently of the universe. Instead, it is an extraordinarily successful tool of thought created by the human mind. This perspective is generally known as mathematical fictionalism or constructivism. Supporters of this view argue that mathematics is a natural product of a brain that evolved to recognize patterns. Our ancestors constantly had to compare, count, measure, and make predictions in order to survive. A hunter needed to estimate the size of a herd. A gatherer had to recognize which trees would produce the most fruit. Over countless generations, these practical survival skills became increasingly abstract until they eventually evolved into what we now call mathematics. The history of mathematics tells a similar story. Ancient Egyptians, Babylonians, Mayans, and Chinese civilizations all developed remarkably different number systems and mathematical methods. If mathematics were truly an eternal and universal reality waiting to be discovered, why did different civilizations reach it through such different paths? Furthermore, human choices play a fundamental role in the very foundations of mathematics. The axioms we choose to accept, the number systems we decide to use, and the rules we establish as our starting points are, to a large extent, products of human decision-making. Even the concept of zero, which today seems absolutely indispensable, was adopted surprisingly late by many civilizations. Likewise, Euclidean geometry was regarded as the one and only true geometry for centuries, until the development of non-Euclidean geometries completely transformed our understanding of space. The renowned physicist Richard Feynman was also cautious on this subject. According to Feynman, mathematics may be the most powerful tool we possess for understanding nature, but that does not necessarily mean it is the fundamental language of the universe. Perhaps mathematics is simply the sharpest instrument humanity has ever created to explain reality. But is there a middle ground between these two opposing views? Some philosophers and mathematicians believe that mathematics is both discovered and invented. According to this perspective, numbers, logical principles, and fundamental patterns are already woven into the fabric of reality. We discover them. However, the symbols we use, the proofs we construct, and the mathematical systems we develop are creations of the human mind. Think of it like a mountain. The mountain exists independently of us. We did not create it. But the trails we carve, the maps we draw, and the routes we choose to reach the summit are entirely our own. Perhaps mathematics works in exactly the same way. The order of the universe already exists. Mathematics is simply the most powerful map humanity has ever created to understand that order. Yet despite centuries of debate, we still do not have a definitive answer. Perhaps we never will. Because this question ultimately leads to something far greater than mathematics itself. What is reality? Can the human mind truly discover reality as it is? Or are we only seeing the models that our own minds have constructed? To fully understand the true nature of mathematics, we must first understand the nature of consciousness, the mind, and reality itself. And those remain among the deepest mysteries humanity has yet to solve. Perhaps after watching this video, you'll never look at the universe the same way again. The next time you gaze at the stars in the night sky or admire the perfect patterns of a flower, ask yourself one simple question. Is the order I see truly a part of the universe? Or is it my own mind that gives reality its sense of order? Perhaps this question will never have a final answer. But sometimes the greatest discoveries are born not from finding the right answers, but from asking the right questions. Now it's your turn. Do you believe mathematics is the fundamental language of the universe? Or is it one of humanity's greatest inventions? Share your thoughts in the comments below. I'd love to read different perspectives, and the most thought-provoking comments may even be featured in future videos. If you enjoyed this video, don't forget to subscribe to the channel and turn on notifications. Because in the videos ahead, we won't just search for answers about the universe. We'll explore even deeper questions together.